Hello. In this module, we will see how to handling confounding variable with R. In any study design, it is very important to find out confounding variable, and once you find out the contribution of confounding variable, then it is to work with separately with confounding variable. What is confounding variable? It is a variable that is playing role in any study designs on the outcome variable in hidden manner. For example, we want to work to find out the exposure of smoking on cancer, especially on breast cancer. Then the hidden factor may be the presence of alcohol also. So, those patients having cancer and those patients having not cancers, out of them some are having smoking or smoker exposure and some of them having not smoker or not smoking exposure. As well as once we find out the 2x2 cross table and explore the influence of smoking on cancer, then we do forget to get the idea about the alcohol. Among those smokers, some of them may be alcohol taker and some of them may not. As well, those who are having non-smoker, among them some of them may be alcohol taker and some of them not. So, once we categorize the variable separately and find out the influence of smoking for cancer and in additional influence of alcohol through cancer, then we can find out the what is the exact contribution of smoking for cancer. That is the example of confounding variable. Here we have to explore the data to in depth way. We have to separately select each and every variable, each and every possible causing variable for cancer, and we have to make a conclusion that confounding factors presence or not. Once we explore the idea about the confounding factor, then separate statistical inference need to be carried out about the confounding factor as well as other presenting factor into the study design. We will see exploring the confounding variables. This is the data, importing the data in R. Here data has been taken from folder. So, this folder path is written here and the data was saved in this txt format. To call the data from txt format, we have used this folder path where the data is saved. After that, we had put the data file name, and to mentioning this variable name initially as the first row, we given header equals to true, and the whole things has been used as a read dot table, and the read dot table is used to import the data from txt file, and it is assigned as my data. Now, when after that we had called the my data and we want to see these first initial 5 observations. So, 1 to 5 comma within bracket given, it shows that 5 initial observations. So, here the ID 1 to 5 are shown, and cancers they were there or not, that is assigned by 1 and 0. So, patients were in cancer assigned as 1, not a cancer lung cancer assigned as 0. So, an alcohol taker or not, so it assigned as 1 if they were alcohol taker, and smoking also, they are smoker or not also assigned as 1 and 0. So, initially 5 individual were smoker and chewing also assigned like 1 and 0. So if the habit of chewing, then it was assigned as 1, otherwise 0. And smoking and alcohol both is having their, then it is assigned as 1, and the combination of smoking and chewing assigned as 1 and 0 also, and alcohol and chewing also assigned as 1 and 0. So these are the variable considered here, and here we will go how to analyze the confounding variable, the data set. Let's see something about the confounding variable. When we are having one exposure and another outcome variable, and we want to find out some third factors is influencing the outcome as well as exposure. In that case, this third factor is called as confounding variable. In nature, it's very difficult sometimes to find out what is the confounding factor or variable. So in that case, we will try to find out, explore as much as possible to consider the variable. Once we consider as much as possible and trying to find out the one by one variable influence on the outcome variable, and thereafter we say that one confounding variable is present or not. So another important thing, not only by analysis, by review of literature and biologically, we also have to find out this confounding variable presence or not. I have to give one example where confounding variable is present. For example, this alcohol and smoking both is having cause for cancer. So if we want to see that alcohol contributing for cancer, definitely we will see alcohol contributing. And if you directly want to see the smoking is cause for cancer, then we will also see that yes, smoking is influencing cancer. But those people are taking alcohol, they are having more prone for cancer if they take the smoke. So here smoking can be considered as confounding variable that influence for alcohol during alcohol taking, and in addition to smoking of alcohol, it proceeds the outcome, that is cancer. So here as an example, and in this module we will also see this example with alcohol and smoking. Now let's start with one by one factor. We will see influence of their on cancer, we will see, and after that if we find that yes, there is presence influencing confounding factor present, then we can make our inference like that. So let's start the analyze data. So this is a scenario 1 where only alcohol as covariates is considered. It can be called as a typically univariate analysis, where cancer is considered as response variable and as a covariate alcohol is considered. So alcohol also decoded as yes or no, that alcohol taking or not, and those are having cancer also denote as yes or no at 1 and 0. So like earlier we have seen the formation of contingency table. So from this data set we can also form the contingency table, and we can find out odds ratio also, that contribution of alcohol on cancer, and if we found the odds ratio coming more than 1, then we can easily make the inference that yes, alcohol consumptions contributing for alcohol cancer. But here we are also, in addition to that, we are putting this modeling, that linear model we are considering, that LM function we are using here for the data set, data equals to my data, and assigning as mod.1 to assigning this model 1. In this model we will see different scenario, and in different scenario we will assume different model. And here the initial model is response and variable relation, that is with cancer and alcohol. And once we put the mod.1 and thereafter put summary of mod 1, and we are putting confidence interval to get the regression coefficients value for mod.1 by putting CUNFINT of mod 1. So this is the results obtained for relation between alcohol and cancer. So intercept is obtained as 0.23000. Standard error of this estimate is obtained 0.1581. with t value 1.897 and p value 0.0739. Where for alcohol it is also coming 0.30, standard error 0.22, t value 1.34 and p value 0.1964. So it states that there is not any significance relation between alcohol and cancer. However, this point estimate is coming positive. The regression estimate for alcohol is coming positive. So we can say alcohol taker having more having positive pattern for cancer, but however this pattern is not significant. So here one residuals also been observed, and residual of standard error is found with 0.5 with 18 degree of freedom, and this fitting nature of this analysis can be carried out by multiple R square. So it shows that multiple R square value is 0.09. so if it varies from 0 to 1, so if its R square value is near to 1, then we can say the model is suitably fitted. In this case, since it is not going near to 1 and is far from 1, so we can state model is not so good here also. Now anyway, we don't have in nature, it's very difficult to find out the exact model, so it should not be accepted in a model that it should follow near to 1, R square value should near to 1. And now we are coming to next functions result, that is conf int for mod of dot 1. So that is giving us the confidence interval for model 1, and that we are getting the estimates for alcohol is 0.30, with in addition to that alcohol's confidence interval we are getting from minus 0.16 to plus 0.36. So as we have seen, that p value was coming 0.1964 and it was not significant. Here also, since this regression coefficient value touching minus and 0 also, window value touching 0, so we can conclude that definitely this regression coefficient value is not positively associated. The significance association of alcohol on cancer has not been obtained in this. Now we will go to scenario 2, where alcohol and smoking as joint covariates is considered. Now again we are putting it as assigned as a mod dot 2, where function lm is used here, and response variable cancer is used with alcohol and smoking here, and data is assigned as my data, and the whole summary result is been considered as summary of mod dot 2. Now the results is residuals value obtained here is coming from minus 0.65 to 0.75. So it makes sense that how your residual is spread over in your data set. Now since we are getting the relation between alcohol and cancer as a regression coefficient value 0.3, here the estimates again we are getting for alcohol 0.3 positive value, and smoking here we are getting 0.10. Again for both the terms regression coefficients value we are getting standard error with 0.2288 and 0.2288, and for t value for alcohol we are getting 1.311 and smoking 0.437 with p value 0.207 and for smoking 0.668. So both p values stating that separately alcohol and smoking has not any contributions on cancer. So somehow this multiple R square is become better in comparison to earlier one. So now it increased to 0.10. So if we go for model effect comparison, then you can state this model is better than in first model, because this multiple R square is better than earlier one. Now we will go for to check the confidence interval of these regression coefficients, that is for alcohol and smoking. In both case you can see that regression coefficients confidence interval started from minus to plus. For alcohol it is minus 0.18 to 0.78, and smoking it was minus 0.38 to plus 0.58. It states that both are having not significant regression coefficient value, both are touching the value 0. Now we will go for scenario 3, where alcohol and smoking with alcohol is considered as covariates. So initially we considered alcohol, thereafter smoking and alcohol. Now we are considering alcohol and the factor smoking with alcohol. So here we can see that again the residual started from minus 0.6 to plus 0.7, and it shows that this intercept value is standing from 0.30 for as a estimate for intercept. Standard error is also very less, 0.1627. T value is coming 1.84 and probability of value p value is coming 0.08, whereas alcohols again having same regression coefficients value, and smoking with alcohol having very less value. However, this value is not significantly, so again the smoking and alcohol having not any contributions on that. So it is to be noted that if we find that alcohol and smoking is having p value significance, in that scenario we may go further to check this confounding factor, how working on that. But when we don't get the p value having significance, in that scenario going further to finding out the confounding factor is not a it should not be advised, but here just for illustration purpose we are showing. But in real life scenario, if we found that alcohol is having p value significance and smoking also having significance, then these additional covariates, that is smoking with alcohol, can be considered to check these influence as a covariates, confounding factor. Now again as a illustration we are finding this confidence interval for the regression coefficients for model 3, and found that alcohol's case confidence interval started from minus 0.29 to 0.89, and smoking with alcohol is started from minus 0.68 to plus 0.66. Since this confidence interval touch again the zero value, so it can be stated that it's not significant. Now coming to scenario 4, where we are considering alcohol and smoking chewing as covariates. So those were smoker and chewer were considered separately with the alcohol, and here we found these residuals standing from minus 0.63 to plus 0.67, where intercept value estimates as coming as 0.3216, standard error 0.1704, t value 1.88 with p value 0.0764, and for alcohol again these estimates, regression estimates coming 0.3108, standard error 0.2305, t value 1.348 and p value 0.1953, and for smoking with chewing coming minus 0.1089. So it can be stated that those were having smoking and chewing more, they are having less chance of having cancer. It shows that, but however since there is corresponding p value is 0.6897, so it's not less than 0.04, so we can't say it's strongly associated that smoking chewing is have both is positively preventing for cancer. We can't say that, but here the tendency shows that majority who are having smoker and chewer, they are having less cancer in comparison to others. So this is since the data set is small, so it may be happen this kind of result, but when we will increase our sample size, this kind of odd scenario may be avoided. Here the residual standard error is considered as 0.512 with 17 degree of freedom. So and the multiple R squares coming again reduced to 0.09965. So it can be stated in comparison to earlier one, the model, as far as model fitting scenario criteria is concerned, this model is not at par or not equivalent to good in comparison to other one. But since we are considering the presence of smoking and chewing here, it can state that those are having more than smoking and chewing, they are having lesser chance to having cancer. Now we will go to scenario 4 for getting these confidence intervals of these estimates. Again CONFIT of mod dot 4 giving us these intercept values, confidence intervals, alcohol's regression coefficients confidence interval, and smoking and chewing's confidence interval. In 3 cases also they are having same, started from negative to positive. So anyhow these confidence intervals things touching the value of 0, so obviously it can be stated that regression coefficients are not significant and data is not influencing towards cancer. Now going to scenario 5, where we are considering alcohol, smoking, chewing and smoking as covariates. So here we are having total 5 covariates considered on the cancer. So again it's obtained that as a summary of mod 5, when we are putting as since the variable is assigned as mod dot 5, and when we are calling summary of mod 5, then we are getting these regression coefficients. Again in this illustration is found that smoking and chewing having negative influence on the cancer, and smoking and alcohol having negative influence on that cancer. However, this multiplied R square is now increased 0.09 to 0.15 and adjusted R square coming to minus 0.0875. So this p value of this model is coming 0.6567. Again it can be stated that these factors are not influencing the response variable of interest, that is cancer. So here we didn't find any variable considered to be as a confounding factor. Now going to scenario 5, where we are considering alcohol, smoking, chewing and smoking as covariates. So here we are having total 5 covariates considered on the cancer. So again it's obtained that as a summary of mod 5, when we are putting as since the variable is assigned as mod dot 5, and when we are calling summary of mod 5, then we are getting these regression coefficients. Again in this illustration is found that smoking and chewing having negative influence on the cancer, and smoking and alcohol having negative influence on that cancer. However, this multiplied R square is now increased 0.09 to 0.15 and adjusted R square coming to minus 0.0875. So this p value of this model is coming 0.6567. Again it can be stated that these factors are not influencing the response variable of interest, that is cancer. So here we didn't find any variable considered to be as a confounding factor. Now we will go for scenario 6, where another combinations alcohol, and smoking is considered separately, and summary statistics has been used to get, and as a summary of mod dot 6 is used to get the summary results, and as a results we can see the multiple R square coming is 0.1111 and adjusted. So somehow again this model fitting criteria reduced with F statistics 0.6, is that F statistics is used to calculate the combined p value, and this combined p value is coming 0.5847, and for separately if we go this p value, we can see this table here that intercept 0.20 with standard error 0.2345 having p value 0.406. Again it's not significant here. In earlier cases we have found that it was significantly intercept value. In alcohol cases somehow the influence of alcohol is obtained here, this influencing more in this combination of the modeling. Again smoking with alcohol again showing there's having negative influence on the cancer. So smoking with alcohol can be preventive for cancer. This is quite funny thing here in this data set, but since this results is showing that we have to accept the fact that here the smoking alcohol somehow influencing preventing for cancer, but in real definitely is not going to be in this data set. It is maybe the limitation of this data set is very small. And now we are going for another variable, that is smoking. Again the estimate of the smoking is coming 0.2000 with standard error 0.3317, and again the p value is coming 0.555. So all these 4 factors stating that there is not any significant associations or influence of this factor on cancer. Now the confidence interval of the segregation coefficients, again coming from minus to one side, lower limit started from minus, upper limit started for plus, and this confidence interval is obtained for 95% significant 95% confidence interval is used here, and here intercept case is coming from minus 0.29 to plus 0.69. For alcohol it is coming minus 0.30 to 1.10, and smoking alcohol again coming wide range from minus 1.19 to 0.79, and smoking minus 0.50 to 0. So again these factors stating that none of the factor is contributing on the cancer. So this kind of work is need to be carried to explore the confounding factors. So one by one factor and the combined effect of these factors, like here we have used the smoking separately, alcohol separately, and again after that we had considered this combined effect of alcohol and smoking separately on the cancer. So these procedures need to be followed to find out to dig out these confounding variable from a huge number of, from a data set having huge number of variables. So once we find out these variables having contributing, having suspicious for contribution as a confounding factor, then again rigorous logical literature support and is required to further to carry it out to establish the fact that few factors contributing as a confounding factor. So two-way confounding can be detected, presence of confounding variable can be detected. One way is through the support of the literature of that specific domain, and other way to doing the exploring the data in different way. So here we are trying to find out the presence of confounding factor with exploring data in different way. However, in this data set we didn't find any factor contributing for cancer, so there is no any meaning to obtain this confounding factor, but the process is given here that is required to follow in real life scenario where we are going to find out these presence of confounding factors. Here we have seen how to handle confounding variable and how to analyze data for confounding variable in R. Here we have considered separate different model, and from these models we have tried to find out the presence of confounding variables, yes or no. We make the statistical inference that how to make inference when we are having data in presence of confounding variable.